Hey guys, welcome back to our channel. Now in this video we are going to understand about the various ways that we can create the neural networks using Tensorflow framework. Now one of the common methods that you're already aware of is like first you'll create an object as sequential, and for that sequential object you'll go ahead and add the various layers. Now to tell you what I mean, I'll just use the same model definition that we had created earlier. I'll just copy this. Alright, and I'm going to paste it over here. And this is what I'm talking about. So I'll just make sure that I'm importing TensorFlow. So import TensorFlow as TF. So create models dot sequential object, and then I'll add various layers one next to each other. That means I'm just stacking one next to each other. So when I just execute this is going to create me a model. Now in this scenario, this is a model which takes the input of the shape 25, 25, 3. And then it is going to flatten it with the help of my flattening layer. And once it is done, it is connected to actually a dense network which is having 4 neurons, and the activation is ReLU activation function. And for this dense layer, I have specified the name as hidden one. And in the next layer, I have created one more dense layer. This also has 4 neurons and the activation function is ReLU. And in my final output layer, I am having a single neuron with sigmoid activation function. Okay, so this is one of the common way that we create a model using this TensorFlow framework. Now, apart from this, another method you would see people using and creating the neural network is by defining the layers inside a Python list, and that is being sent inside this sequential method. Now, to tell you what I mean, I'll just import, since I've already imported, I'll do one thing. I'll say model is equal to tf.keras.models.sequential. So inside this sequential, I'll specify my individual layers. Now this time I'm going to say that, okay, layers is equal to, and I'll mention my Python list. Now here in my Python list, so here I'll just have to say it as tf.keras.layers.flatten, and this flatten layer gets the input of the shape 25, 25, 3. Now after I define this first layer, okay, so I'll have to begin defining my next layer. So I'll say comma, and in my next layer I'll have keras. So I'll just copy this thing, guys. Okay, I'll say tf.keras.dense, and I'm going to specify my name to be equal to hidden one. So this will be my second layer, and this is followed by another hidden layer. So I'll just copy this part and I'll paste it below. Okay, and I'll also specify my output layer. So this is my output layer. So what I am actually doing over here is, instead of specifying and adding one layer next to each other, I'm specifying all the layers inside a Python list. Now inside this Python list, you can clearly observe how I'm stacking the layers. So flattening layer followed by 3 dense layers. I'll just execute this. Now once the model has been defined, and if I display my model summary, okay, you can clearly see that we have the same number of parameters. This means that whatever the models that we have defined earlier is same as what we are actually printing. Now to confirm this, let's do one thing. Let's print and visualize the model. Now to visualize the model, I'll write it like this. I'll say tf.keras.utils. Okay, now inside this utils module, we have a function, and I think that function is called as plot model. I'll say it as model. Okay, so this is how our model definition looks like. So I'm having a model, and see, it is input layer followed by flattening layer followed by a dense layer, another dense layer, and in my output I also have a dense layer. Now the method 3 that we have is, we can also create the model using the functional API. Now how does it look like? So to show you this, let me define my model that would look something like this. So I'm going to say that, okay, I'm having one input, and I'll say that, okay, input 1 is equal to tf.keras.layers.input. Okay, So this is my input layer, and this input layer gets the shape of, I'm going to say this takes the input of 6. Okay, I'm going to say that, okay, this name of this layer, I'm going to call it as a input 1. Then I'm going to define one more layer as input underscore 2. So this input underscore 2 says tf dot keras dot layers dot input, and this actually takes 5. Okay, so in shape is equal to 5, and I'm going to say that, okay, name is equal to input underscore 2. So I have defined 2 input layers. Now using these 2 inputs, let's see how it is actually connected to my hidden layers. Now in order to do that, I'm going to say h1, which is my hidden layer 1, and this hidden layer 1 is defined as tf dot keras dot layers dot dense. Okay, and this dense network has 30 neurons, and the activation, I'm going to use the same activation, that is LLU. Now observe this, guys. When we are defining the functional API, or in the format of this functional API, we actually use this methodology when we want to specify the connection between the neurons, which is not a sequential one. That means for defining a non-sequential models, we'll actually use this functional API type. Now, what this h1 input is going to do is, this h1 hidden layer is going to be applied by taking the input from my input 1. Now to specify that, inside my parenthesis, after the model definition of my h1, I'll say input underscore 1. Okay, and I have one more h2. Okay, so this is another hidden layer h2, and this hidden layer h2 will be applied in this manner. So the way it will be applied is tf dot keras dot, I'll just copy the above code itself. Okay, so this is the same dense layer, and I'll have the same 30 neurons, and this gets the input of my previous hidden layer 1. So h1. Now once this is done, as a next step, I'm going to perform a concatenation operation. Now to perform the concatenation operation, I'll just say that, okay, tf dot keras dot layers dot concatenate, and this is going to concatenate my input 2, okay, and as well as my hidden layer, that is hidden 2, that is h2. Okay, now after I do this concatenation, I'll define my model output like this. I'm going to say that, okay, output from my model is tf dot keras dot dense, and I'm going to specify 1 neuron, and then this time I'll specify my activation as sigmoid, and this output layer, or my final output layer, is applied on the previous concat layer. Now what I have done over here is, I have defined my individual layers and how output should be calculated on the basis of my individual layers configuration. Now once I have defined how the output should be calculated on the basis of the inputs, like to complete the model definition, I'll also have to specify the model. So to say that it's a tf.keras.model, I'll have to mention that, okay, tf.keras.model, and then inside the parenthesis, I'll have to mention what are the inputs and what are the outputs for this model. In this scenario, I have 2 inputs. So input 1 and input 2. And this model has the outputs as, I just have a single output, that is my output. Now once this is done, I'm going to say model.summary, and I'm going to execute this. Okay, so we have the output. Here it says I'm having an input 1, and this input 1 has the shape as 6, and this is connected to my dense layer. See, this is my dense layer, and this has 30 neurons. Okay, that is, I'm preferring this one, guys, okay, which is h1. So let's do one thing. In order to better identify this, let's name our networks as well, like individual layers. I'll say name is equal to h1. In the same manner, I'll specify the name for next layer. So I'll say this to be in h2. And then after I define my concatenation operation, I'll say name is equal to concat. Okay, and finally I'll say name is equal to output. Okay, now observe it guys. See, I have my input 1 and this input 1 is applied on my hidden layer h1, which is what we have defined earlier. And this is followed by my input 2 and this input 2 is applied on my h2. Okay, so here I've just defined my hidden layer h2 and I've defined my hidden layer h2 over here. Okay, this is input 2 and this is h2 over here. And after this h2, it says there is a concatenation operation between my input 2 as well as my hidden h2. Okay, and observe this guys. So when I'm saying it as h2, this h2 clearly says it is connected to h1. And this information was not available earlier. See, we didn't have that information. Since we are building it as a functional API, we also have the opportunity to see as which layer is connected to which layer. Okay, in this concatenation operation, it is connected to input 2 and h2. And output layer is connected to my concatenation layer. Now, in order to get the visualization, let's use the KRS plot model. And then if I just execute this, see, this is how our network structure is. I'm having an input layer and this input layer is connected to a dense layer and h1 is connected to h2, which takes the input from my h1. And after I have this h2, I'm concatenating my both h2 as well as my input 2. And using this concatenated value, I'm actually finding the output, okay, which is my sigmoid layer. Okay, so we have discussed about 3 important types that we can create our neural network. One is with the help of sequential object. So we can define our model as sequential and then add one next to each other by making use as model.add. Or alternatively, we can create the model as sequential and inside the parenthesis, we can specify the layers in the format of a Python list. And the third method that we have seen is we can create the model with the help of functional API. Now, apart from this, we have another method that is called as subclassing API. So in the part 2 of this video series, I'll share you as how we can create a deep learning model in the format of subclassing API. So I'll see you next time. Check out our deep learning playlist on our YouTube and I'll see you next time guys. Take care.